Meteorologist Serena Arnold. If you're excited about seeing the total solar eclipse on April 8th and you're concerned about clouds, there's a new piece of science out there that you're going to find really interesting. Clouds dissipate quickly during solar eclipses as the land surface cools. This is going to be a light bulb moment for my weather weenies because you already know this. The path of totality for the 2024 solar eclipse goes through the following states. And clouds are going to be a killer. And if you look at historical data, the further south and west you go, the more likely it is to be clear. And the further north and east you go, the cloudier it's supposed to be. Now, this isn't an individual weather forecast. It's way too far out for that because it's a month out as of the time that I'm recording this. But if you look back at, say, 40 years worth of historical data and say, what is April 8th going to be bringing us based on the past 40 years, there's like a 70-ish% chance that we're going to be seeing clouds in New England. Now, being in New England, I don't have a plan for the day of the eclipse. I'm going to see it, but I'm going to see what the weather forecast tells me to see if I want to go up to northern New Hampshire or northern Maine, or if I'm going to go west to upstate New York. What's reassuring and amazing, though, is this article from nature.com says clouds go away before the eclipse reaches totality. Now, for this to work, there's two types of cloud types you need to know about. There's going to be the stratus, the high-level clouds that are kind of in this area in the springtime. But then there's the cumulus clouds. And by the way, this applies to the entire path, not just New England. You see, this scientific paper says that even with a 15% obscurity or decrease in solar radiation, that is enough to cool the surface of the Earth enough to cause sinking air and cause those clouds to go away. The authors of this paper viewed 3 separate total solar eclipses and collected data on them. This thing is full of graphics, but here's the clouds before, during, and after the eclipse. And this is all because of rising and sinking air and basically high and low pressure. You see, what's happening is the sun is shining down and the solar radiation gets greater. You have more heat, you have more rising air, which causes that air to rise and condense to form clouds. But as the sun gets obscured by the moon, you actually are going to get a weakening of that, and you might actually have subsidence, sinking air, high pressure. And then after the sun peaks out again, you're going to get an increase of the warming of the land and an increase of the clouds. And the data they have behind this makes me giddy. So they measured cloud cover, cloud thickness, and land temperature, and found that during the eclipse, the blue, the cloud cover dissipated, the clouds were less thick, and the temperature dropped. It's way too early now to talk about the forecast for the total solar eclipse coming up on April 8th. But when we do, we're going to be taking a look at the cloud forecasts along the entire path of totality, so make sure you follow. Because we're going to look at more than just cloud cover. We're actually going to look at the cloud types and see if we can forecast where clouds are going to be dissipating during the eclipse. This is going to be a good one, weather weenies. Stay tuned.